through before we go on to how far and Kc and Kp. The first thing that I want to go through with you is just quickly recap equilibrium and the different rules. So the actual definition that you need to know for your exams is that dynamic equilibrium occurs in a closed system where the rate of the forward and backwards reaction are both equal. So I'm going to show you what that means and a couple of things that you need to know about them. So the first thing that means is the rate of the forward reaction is equal to the rate of the backwards reaction in dynamic equilibrium. This also means that the concentration of products and the concentration of reactants no longer change, and I'm going to explain why in a second. However, a common misconception that a lot of students now think is that in equilibrium, the concentration of reactants and products are equal, when that is not the case. The difference between these two is a big one, and I'm going to explain what it means in a second. So in a normal reaction, let's say for example we have A plus B going into C plus D. Okay, so our C plus D are our products and our A plus B are our reactants. Okay, if this reaction is in equilibrium, that means that the rate of the forwards and the backwards reaction is both the same. Okay, if that is the case, the forwards reaction uses up A plus B and produces C plus D. The backwards reaction uses up C plus D and produces A plus B. Okay, so if these reactions are now both at the exact same speed, then that means that the rate at which A plus B is used up in the forwards reaction is the exact same at which it's produced in the backwards reaction. So therefore A plus B no longer changes. And if the rate at which C plus D is produced in the forwards reaction, that will be the same at which it is used up in the backwards reaction, which is why the concentration of C plus D also doesn't change. So that is just me trying to explain the second point here, which a lot of students get confused up on. Now the third point, this doesn't mean that the concentration of reactants and the concentration of products are the same, because they could have reached equilibrium when the concentration of A plus B was a lot different to C plus D. Therefore, the two concentrations won't be the same, but the concentrations of them no longer change. So these are just a couple of things that you have to be aware of when it comes to equilibrium, that they may ask you about in your exam. Okay, this next stuff should just be easy. This is all from year one. I'm going to go through a couple of different conditions and what effect they have on equilibrium. So let's go through temperature first. It's nice and simple to remember. An increase in temperature shifts equilibrium to the endothermic side. And I'm going to show you a question later on how we apply that. A decrease in temperature shifts equilibrium to the exothermic side. Okay? When it comes to pressure will always shift equilibrium to the side with fewer moles only if there is an increase in pressure. So when we increase pressure, that shifts equilibrium to the side with fewer moles. So if you look at this equation here, this is the Haber process. You should know this equation off by heart. If you look at this equation here, on the right hand side we have 2 moles. On the left hand side we have 3 hydrogens, and there's 1 in front of nitrogen. Obviously we don't write it. So in total, on the left we have 4 moles, and on the right we have 2 moles. Therefore equilibrium shifts right, but that is only for when we increase pressure. If you were to decrease pressure, it's the exact opposite. So if we decrease pressure, equilibrium shifts to the side with more moles, and therefore it would shift to the left hand side for this question here. Okay, the next thing to go through is concentration, and this is very simple. It's just opposites. So if we increase the concentration of reactants, then it shifts to the side of products. So if we increase concentration of reactants, equilibrium will shift right. Whereas if we increase the products, equilibrium would shift left towards the reactants. Hopefully that's nice and simple. If you have any questions, you can just comment and I'll answer them in the comment section below. And catalyst is nice and easy. It has no effect. Now there's a common question. Why does catalyst have no effect? The answer is it will increase the forwards and the backwards reaction by the exact same amount. Therefore, if we increase the forwards reaction and the backwards reaction by the same amount, meaning we make them both quicker by the same amount, then the reaction is still at equilibrium. Because if they were at equilibrium originally, meaning the rate of both the forwards and the backwards reaction was 1, and then we increased both of them by the same amount, then it's still at equilibrium because they still both have the same rate. It's just a lot higher now, but it's still both equal. One final thing I just want to quickly go through with equilibrium is what does it mean if equilibrium shifts right? Okay, there are a couple of things that you need to know. If equilibrium shifts to the right, that means now we are now favoring the forwards reaction a lot more. This means that the forwards reaction will now be a lot quicker. So the rate of the forwards reaction increases. Okay? In the forwards reaction, we are producing C plus D, meaning if now the forward reaction increases, the backwards reaction doesn't increase at all. So now the forwards reaction is faster than the backwards reaction. And we know the forwards reaction produces C plus D and uses up A plus B. So now if the forwards reaction has increased, we have produced more products and we have also used up more reactants. Therefore, the concentration of C plus D will increase and the concentration of A plus B will decrease. And that's everything that you need to know with equilibrium. Just watch out for the next couple of videos. I'm going to make them on KP and KC, hopefully.